Hello and welcome to this video where I'm going to show you how to get started in 3D using JavaScript, and to do this I'm going to use WEBGL and the P5 library, which is made by processing.org, and I've got their reference page for doing some texturing and things here ready if and when I get into some trouble and I don't know what I'm doing anymore. So this is something I've made earlier. And it's just an example of the kind of thing you can do in 3D. Right, but we're going to do something a little bit simpler than this just to get us started. So this is on CodePen, but I'm going to do it in a what do you call it? I'm using brackets. I forgot, like a coding environment. Okay, so in my project, I've just got a folder with, I've got a picture of Red Hen, there he is. I've got my index HTML web document, and I've already got the P5 library attached. This is going to be a very old version of P5. In fact, I should probably go and grab the latest version, because if you grab the latest version, I think there's been some updates to WebGL, and I've got an empty JavaScript file, which is where we're going to start programming, called 3D Tut1. Okay, so first thing, let's just go and grab the latest P5 library. So to do that, if you go to cdn javascript, cdnjs.com, and wait, I can have tea. Okay, that's far too slow. There must be something wrong with my internet. Anyway, we're going to put in p5.js, and here it is. And yeah, we'll get the minimum version. That'll be fine for our needs. Go back to our coding environment, and right, we don't want to get the P5 library from my libraries folder in my project folder. Instead, we want to get it from this URL which I've just copied. So that should be fine. Is that all good? Okay. Right, let's save the HTML file. Okay. Let's just make sure some basic things are working. So first we need to get a canvas on our web page. So P5 starts with the function setup function, and we're going to have a draw loop. So in P5, draw function will loop around and around automatically, and the program will start, or the browser will start at setup. And to create a canvas, we write create canvas, and then how many pixels wide, up and down. Let's just say window width. So we'll just take in whatever window width we've got, and then window height. And then to switch on 3D, a 3D canvas, because at the moment it's just 2D, the third parameter, we write WebGL, I believe all capitals. Okay, let's just set a background color so we can see it. Background, just put in some random colors. I love doing this. You never know what you're going to get if you try not to think about what's going on. Okay, oh, it's quite dark. 201, 32, 12. Right, save that. And so I'm using brackets editor. If you click the lightning bolt up here, it creates like a local server, hides your face, and runs things. Right, and I'm running it in Chrome. Okay, title's working, we've got our icon there, but I don't see a canvas. So let's just bring up the console. I'm on a Mac, and that's Alt Command J to bring up that. Where's the console? Right. Create canvas, not defined. Right, just silly typo. Canvas. Canvas. There we go. Let's save that. Let's hope that was the only problem. Run again. Make sure you save your sketch. Oh, I've got a nice red. I kind of like that. We mean business. We mean business. Right. So hopefully we've got a 3D canvas area. So now I really should have done some planning. I can hardly remember anything. Let's just see if we can render a sphere in the middle of our window. So let's go and make some variables straight away. So let's say we'll call it, what should we call our planet? Like, I usually get eggs involved. Egg planet, right. So I'll call it EP for egg planet X. And then let EP Y, and then Z. We can use the Z axis. Let EP Z. So we've got three axes, three positions, positional vectors, positional variables. So X left and right, Y up and down, and Z towards you and away from you. There we go. Right. So in our draw loop, let's call the function render egg planet. There we go. So now we need to go and write that function, of course. I'm going to write my functions down here. Okay, function render egg planet. And now we can do the real 3D stuff. So I think we can write sphere, and then we need to give it its location. No, we don't. First, we need to translate. We need to write translate, and that will move us to our starting position, and then we're going to grow our shape from that position, if that makes sense. So we translate to a position, and then we grow our shape from there. Okay, so translate, and we want to say egg planets X, egg planets Y, and then egg planets Z. There we go. So translated to there, and then we can grow a planet. And I think you just put in its size. It must be its radius. So let's say, I don't know, 200 is just popping into my mind. So we'll say 200. And I believe the sphere function has two more parameters. I think it's something like how much detail you want in the X, its X dimension, and how much detail in its Y. So like how many segments it's going to have. And it's something like, the default is 2416. So we'll leave that blank at the moment. It will just go to its defaults, and we'll play around with having a greater or lesser resolution for our egg planet. Right, so let's just see what that does. I haven't put in any values yet. Let's just put in 0, so at least we won't get null. We might get 0 anyway. And let's just see if we've got an egg planet. A problem might be that we're inside of it. Oh no, it's kind of worked. We're in 3D now. So we've got an egg planet in front of us. I was going to say, 0 on the Z-axis should kind of be like in line with our eyes, but I think P5, it may be it'd probably be P5. It's going to be a common problem, so I think it assumes that Z is kind of like automatically pushed away from the viewer or the camera. You can kind of think of it. Our view position is kind of a camera. In WEBGL P5 you can have cameras and move them around. Or you could move your entire scene around and it will kind of mimic or be equivalent to what a camera can do. So let's do something with the Z-axis, this EPZ variable. P5 it's got a lot of handy functions for input and things like that. I mean, you can see how quickly we've got started here. So let's say function. No, let's not even do that. Let's before we draw our egg planet, let's say egg planet Z equals mouse Y. Okay, that's quite dangerous. So basically, if we move our mouse up and down on the Y-axis, then the the planet should get nearer or further away. Whoa! that's a complete disaster. I don't know what happened. Let's just rerun. Oh. Okay, there we go. It doesn't like me going backwards, interestingly. Maybe it's drawing over itself. Do I have to redraw the background? So maybe what was just happening was that kind of, as the planet got bigger, it was just drawing over itself and it couldn't get smaller because, I don't know. Let's just see if that changes that. Okay, moving down. No. I think it automatically changes. Automatically redraws the background, I mean. I don't know. Right, so what we kind of want to do here is kind of map our Y position of the mouse to something more reasonable. So let's say EPZ equals map, and we're going to map it onto the mouse Y position. So this is a keyword, mouse Y, capital Y, that P5 uses, that obviously just gives you the pixel position of the mouse on the Y or the X axis if you have mouse X. Okay, so we want to map between, I reckon, between 0, I think it's already at 0, and I think going away from the camera is minus. So let's just say something like -10 for now. And then, what are we kind of like mapping from? We're mapping from the mouse positions. So minimally, it can be 0. Maximally, it will be height. Height is another keyword from P5, just meaning whatever this window height is. So your canvas, when it's created, will have two variables associated with it, or two variables associated with it, height and width. So if we change this number up here, height will change kind of dynamically for us. Right, so this time what we're doing, when I move the mouse, EZ's getting mapped onto the mouse position, and we shouldn't be able to have silly results now. So it just disappears. Why did it just disappear? Oh! Okay, so my mouse is at 0, and I'm moving down. So height, as the mouse Y number is getting bigger, our Z number is getting bigger on in terms of the negative axis, which is what we want to do. That's disappearing already. Right, I don't know if is -10 to, should I go -10 to 0? Let's try that. -10. Because we're dealing with a 0 with a minus number, do I have to kind of invert how I'm mapping things? Is that what's going on? Let's see. Okay, now we're inside of our ball. No, now now it's going somewhere else. Let's try not moving it back so much. Or maybe I put these parameters the wrong way. Maybe we have to say mouse Y can go from 0 to height. I think this is it. And we want our planet to go from 0 to about -10. Okay, did that make sense? Let's just see if it works, and then I'll re-explain that. Okay. So starting at the top. Yes, that's worked. Okay. So our planet is moving back 10 units by the time we get down to height. So let me just explain that. So the map function maps from the mouse Y position, and first you have to state mouse Y's kind of range. Second two parameters are the range that you're kind of interested in terms of changing this variable. And I think I'm going to increase that from to 100. So now we'll see a bit more movement. But it will mean our planet can never on the Z-axis, it can never get more than 0. At the moment, in its starting position, it's at 0. And as I move the mouse down, it's getting, it's moving down the negative Z-axis. When I get right to the bottom, that's -100. There we go. Lovely. Right. Next step. It's quite fun to play with. Next step. I kind of want to get some lighting involved, but I've forgotten how to do lighting. So maybe I can do that in the next video, unless I remember. Let's throw a texture on him. So first thing we need to do, I've got a texture ready, remember? I've got this, and it has got alpha. I've got a PNG file. So JPEG, they can't hold alpha, can they? But PNGs, they can. Right. So first thing we need to do is store that image in a variable. So let's call that our red hen texture. Okay. So in our setup, this is a good place in the setup function to go and load textures. Let's say, how do I say this? Red hen text equals load image. Is that how I do it? And then the argument that I pass in needs to be the path to this file, which I just think is where, yeah, it's in the same location as this script. So I don't need any slashes or anything like that. I'm not going into any other folders. So I just need to write the name, red hen icon alpha 512 by 512.png. There we go. And I think in brackets, if I hover over the name and I've got the name right, it will preview the file according to the path, which is good. Okay, so what have we done so far? We've loaded that image into this variable, RH texture. And now, before we draw or before we render our egg planet, we can say that our texture is going to be red hen text. Okay, and then what WebGL will do, P5's WebGL, it will apply that texture to any primitives, any shapes that you then create, I believe. Kind of like a state machine or something. Right. Oh wow, okay. It's worked. I've got our texture on the planet, and the alpha zones of that texture are see-through. There we go. So really, we definitely now need to get the planet rotating on its axis. So that's going to be the last thing I do, I think, because we've got WebGL working, we've got a shape, and we've got the basic principles of the axes, like the z-axis and that kind of thing. We've got a bit of mouse interaction, we've got a texture on there. Let's just get this rotating. Right. Rotating. So when we draw it, you should do your translation, so you can, what a translation does is move to the center of that object. Only after you've translated, then do the rotation. Else, if you do the rotation before translating, you're going to rotate the whole scene, and your object is not going to rotate from its center point. So we're going to say rotate, P5 function again, for dealing with 3D or 2D, you have 2D rotations. We want to rotate our planet on its y-axis. So imagine a pole sticking through it. It's going to rotate like a kebab or something on that axis. And now I've forgotten what to put. I know that it takes radians, not degrees. And if I just put in 1, I can't remember whether it just puts it at rotation 1 or it rotates it by another 1 each time it goes round, with each frame. Let's just put in 1. So what the radians does here, so I've got a function inside of as an argument. Radians will take a number in degrees and convert it to radians. So it'll return 1 degree in radians. Right. Let's run this and see if we've got a spinning planet. No, we haven't. So I can't tell whether it's rotated by 1. So let's let's put that in a function, a variable up here. Let's say let egg planet rotation equal 0. And then before we rotate it, you know what? Because we're changing its variables up here, we'll change variables up here. And the only job of this function should be to render the planet. So actually we should say, what did I call it? Egg planet rotation. There we go. So this function only translates rotates, fair enough. But if we want to change its rotation, if we want to change its direction, we'll do that somewhere else. So that each function is doing one thing at a time, which is better coding practice usually, I think. So egg planet rotation plus equals, let's put 0.1. I'm always scared of putting large numbers to begin with. Let's put 0.1 and see if we rotate. It's working. It's working. That worked quite quickly. There we go. Our colour scheme is quite cool. It's like red on red. And we've got our rotating shape. Very nice. Okay, right. So you can probably do quite a lot with this already. You can create spheres at least. If you want a cube, you write box. And I would go on to the, where are we? The P5 website. And there might be a better, like, let's just have a look. Let's just write P5JS WEBGL GitHub. There might be some GitHub help. Getting started with WEBGL in P5. Looks like I've already been here. There we go. So this will be a great resource. In fact, let me copy it now. So when I post this video, I'll put this in the description. I think this is a great piece of documentation for understanding how to use all of these functions. After I've kind of got you started, this will take you a lot further, a lot further. And I think I'll make a few more videos. I don't know when. Leave any comments in the comment section for any requests of what we do next, if I haven't made the next video yet. Thank you very much for watching, and I need a Star Wars phrase, and just be nice to Wookiees. Just be really nice to them.